So today we're going to be talking about transcription in prokaryotes. So right here I have a little background on the origin of replication. With prokaryotes you're going to see rolling circle replication or theta replication. This is rolling circle right here. As you'll see right here you have a continuous replication and that's going to be the leading strand. And then over here you're going to have the lagging strand with discontinuous replication, which leads to the Okazaki fragments. So in initiation of transcription, I have the direction of transcription going to the white, downstream is going to be going to the right, and then going to the left is upstream. So at the +1 nucleotide, that's where transcription is going to start. So in order to start, you do have to have a hollow enzyme, which is going to be a combination of this core enzyme and the sigma factor. So the core enzyme is what's actually going to allow the RNA polymerase to begin the transcription at the +1. But the sigma factor is going to help the core enzyme figure out where to go, which is going to be this +1. That's why I say it's sort of like a landing pad. So once it has arrived at +1, the RNA polymerase, translation and transcription begin at the same time. The rNTP helps the RNA polymerase translate and transcribe the DNA into RNA. So after a few nucleotides have been added, the sigma factor is going to go away because it's not needed anymore. And then additionally, with each addition of nucleotides to the coding strand, it will begin to elongate. And the DNA polymerase is actually going to add 3'OH to the new nucleotides, which will make it elongate even more, which ligase later is going to seal any gaps made. So in the case of termination, there are two main ways that it happens with prokaryotes. So what's going to happen is, one way is Rho is going to act as a helicase, which a helicase is just going to break the hydrogen bonds as it moves along the DNA. So this is the DNA-RNA hybrid before the Rho. This is the Rho, this is after, just a little picture. And then the other way is going to be with the hairpin termination loop. So that's going to be right here. So with a hairpin, you're going to have basically corresponding nucleotides on each side. And what's going to happen is they're going to create this loop that are all the nucleotides that go together are connected with nitrogen bonds, and that's going to cause termination. So now that we're familiar with the transcription in prokaryotes, we have this example where it's basically saying if we were to add a base pair that codes for this amino acid in between the -35 and -10 area, what might happen? So in this case, you're going to be adding an extra base pair to the DNA, which is going to be added whenever it's coded. So in this case, I do believe it would result in a mutation that could end up being lethal.